Hello students, now we are taking one more question from your exercise 8b of the chapter remainder and factor theorem. Question number 7th, it says if x plus a is a common factor of expression f of x equal to x square plus px plus q and g of x equal to x square plus mx plus n, then we have to show that a is equal to n minus q over m minus p. So here I am taking x plus a is equal to 0. So this implies x is equal to minus a. Now since x plus a is a common factor of both the expressions, means of f of x and g of x, then we have f of minus a is equal to 0 and g of minus a is also equal to 0. Since both are equal to 0, therefore what we have f of minus a is equal to g of minus a. Now in the expression f of x, x will be replaced by minus a, and also in the expression g of x, x will be replaced by minus a. So this implies a square means minus a square plus p multiply minus a plus q is equal to minus a square plus m multiply minus a plus n. So this implies a square minus ap plus q is equal to a square minus am plus n. Now from both the sides a squares will get cancelled, so this implies minus ap plus am. I'm taking this minus am down on the left side, and n minus q. Now from these two, since we have to find a, so I'm taking a common, so m minus p is equal to n minus q. I have taken positive term first here. So now this implies a is equal to n minus q over m minus p, hence proved. Now I'm taking one more question from your next exercise 8c. I'm taking question number 11th. The question says when the polynomial x cube plus 2x square minus 5x minus 7 is divided by x minus 1, the remainder is a, and when x cube plus ax square minus 12x plus 16 is divided by x plus 2, then the remainder is b. We have to find the value of a if one condition is given 2a plus b is equal to 0. So for this we will find a and b first, and then we will use those values in the given condition. So proceeding to the solution part now, f of x is given as the first expression, so that is x cube plus 2x square minus 5ax minus 7. So and this is divided by x minus 1. So I'm saying since x minus 1 is equal to 0, so from here I get x is equal to 1. Using the remainder theorem, the remainder here is f of 1 using the remainder theorem. So remainder here in the first part it is given as remainder is equal to a, so this will be a, and in the expression f of x at the place of x I am using 1. So a will be equal to 1 cube plus 2 multiply 1 square minus 5a multiply 1 minus 7. So from here we get 1 plus 2 minus 5a minus 7. So a is equal to minus 5a, 2 1 3 minus 7 minus 4, so minus 5a minus 4. So this is the value of a. I am naming it as equation number 1. Now g of x, the other expression, is given as x cube plus ax square minus 12x plus 16, and this is divided by x plus 2. Since x plus 2 equal to 0. So from here I get x is equal to minus 2. Now the remainder is equal to f of minus it is g of minus 2, and here it is given as b. So now b is equal to, in the expression g of x, I will replace x with minus 2. So now b is equal to minus of 2 cube plus a multiply minus 2 square minus 12 multiply minus 2 plus 16. So now this will be equal to minus 8 plus 4a plus 24 plus 16. So this is equal to 4a 40 minus 8 32. So plus 32. So this is b now. So from here we get b is equal to 4a plus 32, and I'm naming this as equation number 2. Now here 2a plus b is equal to 0. This is given in the statement. So using 1 and 2. So using equation 1 and 2, we get 2 multiply minus 5a minus 4 plus 4a plus 32, and this is equal to 0. So this implies minus 10a minus 8 plus 4a plus 32 equal to 0. So minus 10a plus 4a. So this becomes minus 6a, and 32 minus 8, it is 24, plus 24 is equal to 0. So now taking 24 on the other side, so it becomes minus 24. Now on solving this, we get a is equal to 24 over 6. So that is equal to 4. Therefore a is equal to 4 is the required answer. So now I hope that you can complete this chapter, remainder and factor theorem. Thank you. Have a nice day.